If you recall with our exponents and multiplication, I said that anytime they had the same base, we would add the exponents. Same idea. Now, what's the opposite of multiplication? It's division. So what's the opposite of addition? Subtraction, right? So if I had, let's say, 7 to the 8th divided by 7 to the 3rd. Now, do I have the same base? Yes, I have 7. So if I'm talking about division now, instead of doing 8 plus 3 or 8 times 3 or even 8 divided by 3, remember in the example like before, if I said, say I had 3 to the 4th times 3 to the 2nd, you would add them and you would say this is 3 to the 6th. So again, since I'm doing the opposite now, I should say that this would be 7 to the what? It would be to the 5th power. To see that visually, 7 to the 8th would look like 7 times 7 times 7 times 7 times 7 times 7 times 7. Uh-oh. Ran out of space. Let's do this. There's 7 to the 8th, right? 1, 2, 3, 4, 5, 6, 7, 8. Now, divided by 7 to the 3rd. 7 times 7 times 7. Okay, when you simplify fractions, you can always, like say if I had 8 over 2, I know that 2 goes into 2 once and 2 goes into 8 4 times, right? Simplifying. Also, same idea, 7 goes into 7, 7 goes into 7, 7 goes into 7. They cross each other off. I'm left with how many 7s over here? There are 5, so that's 7 to the 5th. Algebraically, it would be like this. A to the m divided by a to the n, just like what we said before. If we have the same base, which we do, a and a, right? So what do? We subtract those exponents, so we'd say it's a to the m minus n. Make sense? So let's do an example algebraically. Let's say I said x to the 4th divided by x to the 2nd. Okay, 4 minus 2 is 2, so I would be able to say that it's x to the 2nd, and that's it. Of course, for those who are visual, they would be really like over 1, because what I'm saying is this 4 minus 2, right? They take these away, and that leaves x to the 2nd over 1. But that we know anything over 1 is just x to the 2nd, like that. Let's try another one here. Let's say I said 10 to the 3rd divided by 10 to the 2nd. Well, what does that visually look like? That would look like 10 times 10 times 10 divided by 10 times 10. And like I was saying before, we can kind of cross them off if they cancel each other out like that. That leaves me with just a 10 on top, which is like 10 to the 1st. So it'd be 10 to the 1st over 1, which simplifies to 10. Now, back to what I was saying before, if you just think about a subtraction, you'd say it's minus 2 minus 2. Okay, well 2 minus 2 is 0, so that's gone, so that leaves us with just that 1 down there. Up here, we have 3 minus 2, which is 1, so it's 10. So what happens, though, if we get 0 as our exponent? Anything to the 0 power is 1, and I think we know that as a rule, but why? Let's see. Let's say I did 3 to the 4th over 3 to the 4th. What does 3 to the 4th really mean? It means 3 times 3 times 3 times 3, right? Divided by 3 times 3 times 3 times 3. Okay, let's cross these off. This 3 cancels that one. They cancel each other. They cancel each other. They cancel each other. Uh-oh, I have no 3's left. But 1 over 1 is the same thing as saying what? 1. And before you go ahead and say, well, but then there's no numbers there, what I mean by when I'm crossing these off over here, what I'm doing, I'm saying 3 divided by 3 is 1. So I just didn't write it, but what it really would look like is 1s is for each of these. What I'm saying is 3 divided by 3 is replaced by 1. Like in my example here, when I said 8 divided by 2, what I meant was 2 goes into 2 once, 2 goes into 8 4 times, which gives me 4 over 1, which is 4. This is the same idea, just shorthanded it. So right here, when I'm crossing them off, there's really like a 1. So that's how I ended up with 1 times 1 times 1 times 1, which is 1. Let's say I had this example of negative 8 to the 2nd power over negative 8 squared, which is to the 2nd power. Again, I do minus 2, I subtract those exponents, which gives me the 0 power. So that's why I've got 1. Now visually, this should look like negative 8 times negative 8 divided by negative 8 times negative 8. And so like I was saying, how many times does negative 8 go into negative 8? It's 1, correct? How many times does negative 8 go into negative 8? 1. So I have 1 times 1 over 1 times 1. 1 times 1 is 1 divided by what's 1 times 1? 1. 1 over 1 simplifies simply to just 1. Let's do some mean awful curveball. Let's say I had b cubed over b cubed. But now I'm going to put something extra to you. I'm going to put a coefficient in there. I'm going to put 6 and 18. Okay. 6b cubed divided by 18b cubed. If I were to write that out expanded, I would say that's 6 times b times b times b. Forgive me, that's a 6. Divided by 18 times b times b times b. Okay, let's go through and simplify. B divided by b, right? Just the 1. B divided by b, we've got 1. B divided by b is 1. Now I've got 6 and 18. Okay, before I was doing it with the bigger number was in the numerator and the smaller number was the denominator, but now I've switched that up on you. Still the same rules though. How many times does 6 go into 6? 1 time. How many times does 6 go into 18? 3 times. Now if you multiply out everything that's left in that numerator, you'd say 1 times 1 times 1 times 1 is 1. On the denominator, we'd say 3 times 1 times 1 times 1 is 3. So our answer is 1/3.